Okay, let's continue from the last video. I'm working on question 16 and I'm solving a question about point of inflection. So you just take the second derivative. If they give you f, you need to take the derivative twice. Well, since they give you f prime, it saves some work. So you just need to take it once, become second derivative. And then you need to know some basic of polynomial. This is a cubic function. It has a double zero at 0. It has another 0 at 3. Its leading coefficient is positive, so the function will be like this, right? Like that. And where is the point of inflection? Well, since here they didn't change sign, it's remain negative. The concavity didn't change around 0, so that's not the answer. The point of inflection will be here. The point of inflection will be at 3 because before that the concavity is negative, it's concave down. After that it's concave up, so the concavity changed. The answer is A. Okay, so let's try. Question 17 is about average value. Okay, when you have average value, you have a formula. Between 6 and 4, you take the total area of the function from 6 to 4, right? And then if you, right, that's the average value. This gives you the average value. Now, be careful. If the question asks for average rate of change, it's not average value. It's about the rate of change. Then you need to take the derivative. If the question is what's the average rate of change from 4 to 6, then you would do this. You would do f of 6, right, minus f of 4 over 6 minus 4. So it's different thing. It's very similar, but I saw that people mix up the two things. One is called the average value. One is called the average rate of change. Then you do the derivative. Okay, good. Question 18. All right, we have a rectangle, right? All this information just tell you have a rectangle with this height and all that. The height of the rectangle will go along the curve here. So the height will be 1 over x squared, the y component. They ask you what's the area, well, and then maximize the area. What does that mean? What's the extreme value for the area? What does that mean? Which means you need to take the derivative, let it be 0. That is your critical point, right? That's your critical point. That is a potential candidate for extreme value, which is the maximum minimum. For application question, you just let your derivative be 0. In application, it has to be 0. But for general question, finding maximum minimum of any function, you let the first derivative be 0 and let the first derivative be undefined. Both of them will be the candidate for critical point. Okay, so first write what's the formula for area? Well, you have a rectangle there. The base is base times height. The base is x minus 3 is the base. What's the height? The height is bounded by that function 1 over x squared. So if you expand it, it's very simple. It's just 1 over x minus 3 over x squared. So that's your A. And now to maximize the area, you take the derivative of that. You know how to do that. Just derive that and let it be 0. You solve it, you get the answer. Okay, so it's question 18. So you just need to know what to do. So going over this MC, once again, you read it, try to understand it, and then every question you understand, you will get 1 more point in the AP exam. So let's try question 19. What are all values of x for which this is equal to 0? The first thing is when you have an integral from 2 to 2, hey, that will be 0. So one answer is when x is equal to 2. See here, x equal to 2. So by looking at the solution, already give you some hints. So this 2 is not the answer. Like 2 to 2 will give you 0. The next one is if you visualize the graph, how does T3 look like? T3 is an odd function. It's like the symmetrical, this one here. So if the end bound is 2, and you want the area to be 0, if your right bound is at -2, then this area and this area will be equal. One top, one below, you add them together, becomes 0. So the answer is -2. So the answer is D. And you look at all the choices, right? Like actually, they give you some hints, right? You have this number, so tell you, hey, 2 may work, -2 may work. Well, will 0 work? Or something, right? 0 doesn't work because look at the graph. The 0 is this part. From 0 to 2, the area is this shape there is not the area is not 0. Okay, so the answer is that. Let's try question 20. Now, let h be a function defined like this. So this is h, And what is the equation for the line tangent to the graph of h? If you want to find something tangent to the graph of h, what does that mean? Well, something tangent, you want to find the slope that just touch, right? So it's about, tangent line is about finding the slope. So let's find the slope of h. Well, what's the slope of h is dh dx. Find the slope of h. H is a function of x, so dh dx give you the slope. So here, on this side, you have a h, and then you add a d dx to that, right? You have a h, you add d dx. So on this side, you do the same thing. D dx, what's h equal to? Well, h equal to this. Does that look familiar? Yes, this is the second fundamental theorem of calculus, right? Here you have the same variable, and here you have the same variable. If this is not x, let's say if this is 2x, the answer is you need to multiply by the chain rule, right? The derivative of that. But this is just x, so it's simply substitution. Well, how about the bottom here? It was a. Doesn't matter what it is, it will just disappear. So if you look at this together, the second fundamental theorem Cal U is just sine square x. That will be the answer. And now when x is equal to pi over 4, just plug it there. Is a special angle. Just plug it in, you will get an answer. Okay, well, actually, the answer will be half. Sine x, sine pi over 4 is 1 over root 2. You square that, will be 1 over 2. So the slope is 1 over 2. So here we go. This one has 1 over 2. And the next, well, at which point? Well, at the point of xy. So how to find xy? If you plug this point in here, right, you can find the y value, right? This is your function. What's h? Pi over 4. We'll plug it there. From pi over 4 to pi over 4, the area will be 0. Take an integral. So the points will be pi over 4, 0. So this is where this pi over 4 and 0 come from in your slope formula. Here we go. So that's question 20. Next one, question 21, a numeric question, right? How are you going to do this? A table give a selected value of twice differentiable. So it is just telling you the function is smooth and continuous. Otherwise, it won't be differentiable. Which of the following must be true? So if it's differentiable, that will be the mean value theorem. So why do they mention 8? Right? So if you can find a place where the slope is 8, okay, well, from 1 to 5. So let's see, from 1 to 5, negative 1 to 5, the changes here is negative 48. Well, 18 minus 30, the change is 48. And then 5 minus 1, so the changes is 8. So according to mean value theorem, there must be some value of x between this interval. If the secant line, the slope is 8, there must be some value in between where the derivative of that is also 8. So B is the answer. All right. Given is a twice differentiable function. Okay, so let's try another question. Oh, this one is good. Question 22. Okay, let's see. Let's do this. They give you a question, they give you the acceleration, they give you information about the position, and then ask you to find the velocity. All right. The position, you derive it, is velocity, right? Velocity, derive it, is acceleration. Now you give it the other way around. So now if you do the opposite, if you integrate the acceleration, give you velocity. If you integrate the velocity, give you position. So let's integrate the acceleration, right? Integrate the acceleration. Okay, here, now, so if you integrate that, t is half, right? T is to the power of half. To integrate it, you add 1, so become 3, 2, and you swap it, put it in the front. So you have 15 times, you swap, you add 1 to the power, swap it, put it in the front. And don't forget to do what? To do plus c. Okay, so the velocity will be 10 t3 2 plus c. Well, you don't know what c is, and this you are not given information that can help you solve for c because you didn't give any information of the velocity, but they give you position. So let's keep going. Okay, the position is taking the integration of that. So you just integrate this thing. Well, let's integrate 10t 3 to the power of 2. Well, you add 1 to 3 to the power of 2. The 10 is here. You add 1 to 3 over 2 will be 5 over 2. You swap it, put it in the front. All right. So here we go. Well, what's the integration of c? Hey, a lot of students miss that. C is just a constant. Integrate that will be ct. You add the variable there. And then you plus another constant, right? Every time you need to, when you take an integration, you need to add a constant. So let's add a d, whatever. So this is my equation. Okay, so students don't know what to do here. You can still integrate c, and then you just get a ct. Cx, or whatever, like whatever variable you're working. So with that, if you now plug in when time is 0, plug a 0 here, plug a 0 there, these two terms cancel out, and you find out d is equal to 10. And once you find out d is equal to 10, right, change d to 10. Now you plug in another point, let t be 1. See, they give you good number. All this become 1. This is a 4. 4 plus c plus 10 equal to 20. So you find out c is equal to 6. So therefore, if you ask now what is the velocity? The velocity is 10t 3 over 2 plus c, but we solve that c is equal to 6. Here we go, c is equal to 6. What's the velocity when time is 0? So when this is 0, the velocity is 6. See, you get an answer there. So this is how you do it. All right, the next question. I will do two more questions. First one, 24, is a related rate question. It's either in multiple choice or in long answer. All right, so here is in a multiple choice. So you read. Okay, the velocity, the volume, they give you volume, and then it's in terms of R. And then they tell you the circumference, okay, is increasing at a rate. Oh, let's phrase that, right? The circumference, let's call it C. Changing, what's the unit? Feet per hour. So it's divided by time. dc dt is equal to 5 pi. So this is what given. They tell you when the circumference is a pi. So this is given, all right? And then they ask you what's the rate of change. They ask you what's dv with respect to, now look at the unit, time. See, they give you all that information. So looking at what you have, I need to find, so look at all here, everything I have v and c. This is what I'm dealing with. I need v in terms of c. However, they only give me v in terms of r. Then you ask yourself, what's the relationship between r and c? Well, c is 2 pi r, right, circumference. So r is c over 2 pi. Well, let's plug it in that formula. V is R, which is C over 2 pi, to the power of 3, you 3 to the power of 3, the whole thing, over 3. And now expand it. 2 to the power of 3 is 8. 8 divided by 3, right? Put it in the bottom. So 24. Pi to the power of 3 is pi 3. That's quite weird, but this is, you do that. So this is my phi formula in terms of C. So this is your primary equation. You always do that. Now you derive it with respect to another variable called t. So therefore you do it implicitly. So when I derive it, this is not the c. When you divide by c, you put the 3 down, right? C2. You just copy the number there, right? Pi 3. And then you don't forget to multiply by dc dt, right? Like because the variable is not t, then you just put dc dt. Now basically you have everything you need. Like this is 5 pi, you put it there. You plug in 8 pi for the c here. Then you just solve it and then you will have an answer. All right, last question, 25. The key is recognize this. This is the definition of derivative. So you need to find out what function is that, right? The definition of derivative is f of x plus h minus f of x over h when h is taking limit x approaching 0. So you try to match the form, find out what the function is, find out what the point is. Okay, so try that. The answer will be B, I think. So give that a try. Okay, that's